Okay, so today we're going to be talking about solving rational equations, and remember, expressions and equations are different from each other. And so let's see if there's a little bit of room here. I'm going to write a couple of things here for you. Good things to keep in mind on what we're going to be doing. Let's see, let's do purple here. All right, so when we're simplifying, it wanted to work to start off with, but what happened here? It keeps doing something weird. I don't know why. All right, let's see. So when we're simplifying rational expressions, we must keep the denominator. Okay, so that is super important. And then today we're going to be solving rational equations. We are going to kill the denominator, right? Because why work with fractions if you don't have to? It's just a good rule to live by. So let me ask you this. What is the difference between an expression and an equation?
An equation will always have like an equals. An expression doesn't always have to have that, I believe.
Yeah, it never has an equal sign in it. So yeah, you're exactly right. It starts with an equal sign in it, right? So if I had something like 3 over x plus 2 minus 5 over x minus 1 equals 12, that's an equation, right? And so we're trying to find x. And so I'm going to show you today how we're going to kill off the denominators so we don't have to deal with that, because that looks kind of hard to solve for x when our x is in the denominator, right? But with expressions like that we've talked about before, if I had something like 1 over x plus 4 minus 3 over x minus 2, that's an expression. And so this is like when we're adding and subtracting fractions, we got to keep that denominator. Okay, so I just want to make sure in your mind you keep these two things straight, because that's probably one of the most commonly missed things on this upcoming exam, is just getting those two things mixed up. Okay. All right, so let's get into this, what we're going to be doing here. So again, like we've talked about a lot, we are going to do a lot of factoring, okay? And almost every single problem on exam 2 is going to require you to factor. So it's so important to make sure you have that down. I keep saying it over and over in these videos, and so I hope you're really, taking that to heart, because I don't want to be like, I told you so. I want you to be like, yep, you told us, so I studied it. Okay, so we're going to factor everything if we can, if there's anything to factor. Then we need to determine our restricted or excluded values. So let's just take a look at this one here. It's kind of a simplified problem that we can kind of look at to start off with. And so right now there's nothing to factor. So we are good there. But now we need to determine our restricted values. So that basically we're trying to figure out, what can x not be? So I'm just going to put here, oh my gosh, I'm sorry, this is just being a little temperamental today. don't know why. Sorry about a pop-up, and I think maybe this is why it keeps doing this. Let's see if this will work now. Okay. All right, so on this first problem, there isn't anything to factor, and so we need to look for our excluded values is what we're going to do. Here, just a second. So,
I don't think we can see your screen anymore.
oh, thank you. So looking for the excluded values on this, remember the excluded values mean what x cannot be. And so we want to make sure that we are, paying close attention to that. All right, this is not... All right. So we're looking at the denominator, and so sometimes there might be more than one excluded value, but we're looking at the denominator and saying, what value would make the denominator go to 0 on any of these? And on this, like with that x, right, x cannot be 0, because if it was 0, if we did 2 divided by 0, that's undefined. We cannot do that. And similarly over here, 4 times 0 is 0, and then we'd have 5 over 0. So 0 is not a good answer for us to pick. Meaning if we solve this through and we came up with 0 as one of the answers, we'd say that the solution does not exist. Okay, or there's no solution to that. All right, so we figured out what our restricted or excluded values are. Now we need to find our LCD, right? So we've done that before when we're trying to add and subtract these, and so we need to do that again on here. So remember, the LCD has to make sure it comprises of everybody is accounted for, I guess is a good way to put it here. And so I know that 20 is 5 times 4. I'm just going to put it underneath there to help a little bit to see what our LCD is going to be. So if I start off and say, okay, 4x has to be there, all right, because this part right here is the 4x. Well, that x is already contained as part of it, so I don't need to put that x again. And then on this last one, we have the 4, but we don't have the 5. And so I also need to multiply that by a 5. So my LCD is actually 20x, right? And so what I'm going to end up doing here is I'm going to end up multiplying each part by that LCD. So I'm going to take this fraction and multiply it by 20x over 1. Take this second fraction, do the same thing, 20x over 1, and then the last one. Gosh, that is just not looking good here. I should have just rewritten it, I think, so I could spread it out a little more. I'll do that on the next one. And so what we're trying to do is kill off the denominator. And so when I'm looking at this first one, right, we're multiplying it by the LCD so that the denominator will cancel out. It'll be gone. So if I'm looking here, I've got 20 on the bottom, and I want to cancel that out, so I only have a 1 on the bottom. So that means I can divide out that 20 on the top. Okay, similarly here, I've got that x on the bottom that I can divide out with that x on the top. And here I've got a 4x. Well, those x's will divide out, but 4 divides into 4 once and into 25 times. Okay, so let me write down what we have left here. And so we make sure you remember that negative there. So I've got x times negative 3, or that's going to be negative 3x. And then on this next one, my x is divided out, so I'm left with 2 times 20, so that's going to be plus 40. And then I just had the 5 on the top and multiply it by the other 5 there, so equals 25. And now that looks so much easier to try and solve, right? Because there's no denominators. And let me caution you, like when you're killing off the denominators like this, like sometimes I have students that try to put the denominator back in after they've already killed it off over here. All right, it's gone. Don't put it back in there. Okay, we've made it, we've kind of equaled everything out so that we didn't have to have those fractions. All right, so then this just becomes like something we've solved a ton of times before. All right, so let's subtract the 40 over. So I have negative 3x equals negative 15, and then divide by negative 3. And so x equals 5 would be our answer. And then we just want to double check that whatever we come up with for our answer isn't one of our excluded values. And it's not, so that means the solution is x equals 5. And remember, with any kind of problems that say solve, you can always take your answer that you get for x and put it back in place of x and make sure that both sides of the equation say the same thing. Okay, so that's kind of what we're going to be doing on this. And so let's take a look at, let's go to this one. Okay, so on this one, we can see that, yeah, we got to start off by factoring things. So let's get some stuff factored here in the denominators. All right, so we're thinking x times x is my x squared. What times what is negative 6 that adds to be 1? Well, it sounds like we're going to probably use 3 and 2. 3 has to be positive and 2 negative for it add to be a positive 1. All right, and then on this next one, this is a difference of squares because I have something squared minus the perfect squared. So we have, you know, minus 2 squared is how we could write that. So x minus 2 times x plus 2 is how that one will factor. All right, and then on this last one, all right, what times what is 6 that adds to be 5? Looks like we'll probably need to do 6 and 1. And then, where is that button? There's got to be one. Okay, and then on this, we need 6 to be positive and 1 to be negative. Oh, sorry. What am I doing here? No, those are not 6 and 1. I'm sorry, guys. I'm feeling all flustered. Okay, sorry. Do you have another option? Yes, right? What do we want to use here? What multiplies to be 6 that adds to be 5? How about positive 3 and positive 2? That looks better. Okay, so now that everything's factored, we've got to figure out what our excluded values are and then what our LCD is. So let's look for these excluded values. All right, so on this one, it's going to be more than one number. So what can x not equal? Well, what about on this one right here? What could x not be? What's going to make...
Negative 3.
Yeah, because if I put negative 3 in there, right, negative 3 plus 3 makes it 0. That's what I don't want. What else can x not be?
Negative 2.
Yeah, because right here, right, if we put a negative 2 in there, that would make that 0. And one more, x cannot be...
Just 2 itself.
Yep, positive 2. Okay, So we can kind of see where those are at there. Okay, so let me get rid of that. And then let's find our LCD now. All right, and then I'm going to rewrite it so it's easier to see. But remember, we start off with just one of the denominators, and then we want to make sure that every single part has that. So I know that it's going to have to, my LCD has to have the x plus 3 and the x minus 2, because that's what I have here on this first fraction, or in this first, fraction. And then here I'm looking, okay, I've got an x minus 2, but I also have this x plus 2. Oh my gosh, I underlined the wrong thing. The x plus 2 that hasn't been accounted for yet. And so that also needs to be part of my LCD. All right, and then let's just double check that both of these are here. X plus 3, yep, it shows up. X plus 2, it shows up. So that is my LCD. All right, so is that making sense how we're finding the LCD? Just kind of looking at all those factors and making sure you have them all there. Okay, so now let's rewrite this. So I'm going to have okay, 4 over x plus 3 times x minus 2 minus 1 over x minus 2 times x plus 2, and then that equals 2 over x plus 3 times x plus 2. All right, so we are multiplying each part by the LCD, right? Because remember, this is helping us make sure that we can get rid of that denominator there. Okay, let me try this again here. All right, so this one, if we multiply it by the LCD, we need to multiply it by x plus 3, x minus 2, and x plus 2. All right, and these are all on the top. So if it makes more sense to you to put a 1 underneath that to make sure that you see that you're dividing out these ones in green with the ones in black on the bottom. All right, but then we're doing the same thing on this, right? So this whole thing here, and then I'm going to multiply this by the x plus 3 times x minus 2 times x plus 2. And then again over here, do that same thing, multiply each part by this. Okay, so remember our objective here is to kill off the denominators. So just looking at this first fraction part, what we have, I can see, oh, I've got an x plus 3 on the bottom I want to get rid of, so let's get rid of that x plus 3 on the top. All right, x minus 2 with that x minus 2. So now I'm just left with 4 times x plus 2. Is there anything in the denominator? Just a 1.
I think so.
Yeah, just a 1, right? Because we got rid of it. That was our whole plan there. We don't want to write our denominator down. We killed it off there. Right? And so let's do that with this next one. So this x minus 2 with that x minus 2 and the x plus 2. And so that means I have left here is minus, don't forget your minus sign there. And I'm going to put this 1 just to make sure everybody's with me. So we've got negative 1 times x plus 3 was the only thing that was left there. And then we've got our last part here. So we've got the x plus 3's divide out, the x plus 2's divide out, and then I'm left with 2 times x minus 2. All right, and now we're just going to solve that for x, and that looks a lot easier to be solved than what we had before. All right, so let's distribute the stuff through first. That's going to be really helpful. So I'm going to have 4x plus 8 minus x minus 3, right, because I'm distributing that negative 1 through, equals 2x, And that's a 2. That looks a little bit weird. 2x minus 4. Sure, that looks a little bit more like a 2. All right, and now let's just get our x's on one side and our whole numbers on the other side, but let's combine some like terms first. So 4x minus x is 3x. 8 minus 3 is 5. And then I'll keep that as 2x minus 4. Okay, I'm going to subtract my 2x over so I can get my x's together. That just leaves me with an x. And then I subtract the 5 over, and I get negative 9. So x equals negative 9. And that's a good solution because it's not one of my excluded values. So I'll say, yep, that is one I'm going to keep, right, and pick there. All right. Okay, what questions can I answer on that? I know there's a lot of moving parts on these type, and we're going to do another one, so don't be like, oh, we're done with it, thinking that. We'll do another one just to make sure you're feeling comfortable with these.
Personally, I feel like I'm kind of grasping it better.
Okay, good. I hope so. All right, let's try this one now. So is there anything here that can be factored? Well, this last one right here, a lot of times people mess up that factorization of this x squared minus 1. But that is a difference of squares. So we want to make sure that we see that, and this factors to be x plus 1 times x minus 1. And those can't factor any further, right? So again, let's say what our excluded values are. We don't want to forget that. So what can x not be on this?
Negative 1.
Yep, can't be negative 1. X can also can't be 1, right?
Mm-hmm.
So those are our two excluded values. All right, so what would our LCD be on this?
It would be both x minus 1 and x plus 1.
Yeah. All right, so if I'm looking at this, and if I started with that, right, because I said, okay, that's one of my denominators, and so I have to have that as 1. And then I look at these other two and say, oh yeah, they're already contained in there, so I am good. That means that is done. Okay, so that's my LCD that I'm multiplying by this time. So again, I'm just going to rewrite it down here so it's a little bit easier, hopefully. All right, so I'm going to multiply all the parts by x plus 1 times x minus 1. All right, every single part, even if it's not a fraction, right? Every single part has to be multiplied by the LCD because it's helping us clear the other denominators that we need. All right, now this is the fun part where we get to kill it off, right? So we got the x plus 1 on the bottom here that I want to get rid of, and I can see that I can divide it out with that x plus 1 on the top. Because those are common factors, like if I had, 4 divided by 4, we would divide those out to be 1s. That's the same kind of thing that I have here. Here, my x minus 1s divide out, and then on this one, right, all of those divide out. So let's see, what am I left with here when I do this? So on this part, I have 3, and it's kind of hard to read what I put there, but that is an x minus 1 equals, I got 1 times x plus 1. Well, 1 times anything is just going to be the same thing, so I'm just going to write that as x plus 1. And then there was nothing to multiply by that negative 2, so I'll just put minus 2 there. Right, everything divided out, so that made it nice. All right, so distribute that through. I got 3x minus 3 equals x minus 1 when I combine those together. Let me subtract my x over, so I get 2x minus 3 equals negative 1. Add the 3 over. So 2x equals 2. So what does that mean x is?
2 over 3? Or
Sorry, yep, we're dividing both by 2.
I'm lost right now, sorry.
Oh, I'm sorry. So
I looked away.
Oh, that's okay.
Yeah, it's 1. It's 1, right?
Yep, it's going to be 1 here, right? Because, yeah, we had to add that and then divide by 2. So x equals 1. However, x can't be 1, right? We decided that up here because if I put a 1 in place of x right here, 1 minus 1 is going to give me a 0, and it's going to make me divide by 0, which I cannot do. So this is not, do not put x equals 1 as your answer. We are going to just have to put on this either DNE or no solution, right? There is not a solution on this. It doesn't exist. Is that clear why it's a no solution?
Yeah.
So it's really important to make sure that you remember to write down these excluded values, because it's easy to overlook that. Do you see, like if we solved this all and we didn't think about what our excluded values were beforehand, we might just put that that's the answer, when in actuality it is not. Okay. All right, let's do one more here. The other one won't take as long. This one is, this 4.5 has a lot more to it than 4.6. So, okay, so we need to again start off, right, making sure that we have everything factored. So those denominators can't factor here, right? This is going to factor to be, we've got what? It multiplies to be negative 3, that adds to be 2. So I know I'm going to have 3 and 1, and I need a positive 2, so the bigger number needs to be positive, smaller number negative. And so what are my excluded values? What can x not be?
Negative 3 and 1?
Yeah, can't be negative 3, and x cannot be positive 1. All right, so that's always good to make sure we have down. And then what is our LCD going to be on this?
X plus 3 and x minus 1.
Yep, have both of those. All right, x plus 3 and x minus 1. There. So on the top here, you know, it's actually, I mean, you don't need to factor that out. So, you know, start off making sure that you factor all the denominators, but I'll show you what we're going to do with that here in a second. So let's go here. Let me write this out. And I'm sure you can kind of see some patterns that are happening there. And some people are like, why do you have to write it all out and show what's canceling there? And that's just, you know, that's just the proper way to do it, so you can see where it's being divided out. And so I want to make sure that you're understanding that. So every single thing is going to be multiplied by x plus 3 times x minus 1. All right, and now we just need to start killing off our denominators, right? X plus 3 on the bottom, we get rid of it there. And then that's going to leave me with just 2 times x minus 1. On this next one, my x minus 1's divide out, and then I'm just left with negative 1. I got that negative 1 there, times x plus 3. And then on this one, right, we can see, oh yeah, both of my denominators are canceling out. And so that doesn't leave me anything on the top that I have to multiply by, so I'm just going to put that down. So negative x, whoops, let me put it, rather have it all the same color there, sorry. All right, so I'm going to just have this as negative x squared minus 3x. Okay, so like we did before, let's distribute those. We got 2x minus 2. Distribute the negative 1, negative x minus 3, and then equals negative x squared minus 3x. So this one is a little bit different because we've got an x squared term in it this time. And before we haven't had that, we've just had x's. And so when we solve for x's and there's no x squared term, you know, we get all the x's on one side and the numbers on the other side. But if there's an x squared term, we need to get everything over to one side and put it equal to 0 because that is going to help us factor to solve it. So we talked about something called a zero product property in the last module, in module 3, and so now that is coming back to us again. Okay, so I'm just going to combine my like terms here. So 2x minus x is just x. Negative 2 minus 3 is negative 5. And then I want my leading term to be positive. So I'm going to choose to add my x squared over here. And I also need to add my 3x over here. Okay. Because, all right, I'm trying to get everything on one side and put the other side equal to 0. So here I'll have x squared, and I'll add x plus 3x is 4x minus 5, and then now everything was gone there, so this equals 0. So now I can actually factor it to solve it. All right, remember when we did this in module 3? So that's the whole reason, one of the reasons why we needed to know how to factor here. So what multiplies to be negative 5 that adds to be 4? Well, the only way we can get 5 is 5 times 1. And in order for it to be a positive 4 in the middle, we need a positive 5 and a negative 1. And then remember how we just set both of those factors equal to 0 and solve. So I'm going to put x plus 5 equals 0. And then I'm also going to have x minus 1 equals 0. And then now I'm going to solve these. So I'm going to subtract my 5 over. X equals negative 5. Add my 1 over. So x equals 1. Okay, so are both of those good solutions? Look back up to our...
One is not.
One is not. You are correct, right? Because if we put it in here, it's going to make that denominator go to 0, right? We said right up here, it can't be 1. So I'm going to just cross this out. It can't be that. But we still had one other value that was good, so this one is our answer. So in this one, we wouldn't have a D&E or no solution because there is a solution. It's just one of the other solutions. It's called an extraneous solution. So it's like we come up with it, but it's going to make us divide by 0, so we can't use it. Okay, so our answer in that is just x equals negative 5. All right. Questions on that?
Nope.